Hi, I'm Karen Carpenter. And thank you all for joining Audubon Dallas in our first webinar series. This session is part one, getting started with eBird and Merlin. Our mission at Audubon is to protect birds in the places they live for today and tomorrow, and eBird is a vital part of that effort. To protect birds, we need to know more about them. And by contributing your observations to eBird, you can engage in conservation and provide important information about their habitats, ranges, and more. These webinars came out of conversations we've had about encouraging birders to use eBirds and to join us in protecting birds. I'd like to welcome the members of Audubon Dallas and our family from Trinity River Audubon Center and the Dogwood Canyon Audubon Center, and a special welcome to our partners at Prairie and Timbers, Fort Worth, and the Tyler Audubon chapters. Also, our friends at the North Texas Master Naturalists are here tonight, and the customers of Wild Birds Unlimited. These webinars were forwarded far and wide, and we're pleased to see so many people here today. Hop into the chat box below and say hello and tell us where you heard about the webinars. And during the presentation, feel free to ask any questions using the Q&A box. We're going to monitor that Q&A box and save the questions for a question and answer period at the end. After the webinars, the participants will all be sent a recording. So look in your email for that, along with some information from Audubon Dallas. And we are honored to have as our presenter tonight someone I respect immensely for being on the forefront of bird conservation. Blaine Carnes is a great birder and ornithologist who works with the Cornell Lab of Ornithology as the Merlin Sound ID project coordinator for the US and Canada. He has been extensively involved in bird population monitoring projects for the past 17 years, with significant time spent working with the Institute for Bird Populations and their collaborators on the MAPS and MOSI banding projects. He spent 2 years at Carnegie Mellon, Carnegie Museum of Natural History's Powder Mill Avian Research Center. He currently runs the bird monitoring programs with study sites at Trinity River Audubon Center and the John Bunker Sands Wetlands, and the acoustic monitoring program for golden cheek warblers at the Dogwood Canyon Audubon Center. Blaine is currently the eBird regional reviewer for 15 counties in North Texas, and we are lucky to have him in the DFW area. And we'll turn it over to Blaine.
All right, thank you, Karen, and thank you everyone for coming tonight. I'd like to get started on the slides. I've got a whole lot of ground to cover, and I'll probably be moving fairly quickly. So if you're familiar with eBird and Merlin, this webinar will probably be covering a lot of things that you already know, but hopefully there will be useful information in here for everyone. What is eBird? eBird is one of the largest participatory science projects in the world. eBird is a data collection platform where, if you already know how to identify birds, you can tell us what birds you're seeing and where, and your data gets added to a massive database of over 2 billion sightings of birds around the world. eBird began in 2002 with the idea that every bird watcher has unique knowledge and experience, and that by collecting information from bird watchers everywhere about what birds they saw and where and when they saw those birds, we would be able to plot out the populations and distributions of birds across the planet. eBird is managed by the Cornell Lab of Ornithology and has grown into a collaborative enterprise with hundreds of regional partners, thousands of regional bird experts reviewing the data, and hundreds of thousands of users. To get a sense of the global scale of eBird, let's look at the map of all the observations that have come into the database over the past 23 years. Areas with a lot of people and good internet access are well represented at this point. but people have contributed their bird sightings from all over the world, from the Arctic to the Amazon to the Antarctic, to remote oceanic shipping lanes and all points in between. This map represents the combined efforts of 1.1 million birdwatchers in 253 different countries. To look at it more closely, that's over 97 million checklists, 73 million photos of birds uploaded with those lists, and over 2.5 million sound recordings of birds, and we're coming up on 3 million at this point. That is a lot of information. This information is what we use to build Merlin and to study birds on a global scale. What do we do with all that information? eBird is a way for anyone around the world to store their birding observations, photos, and sound recordings and make them available to educators, scientists, and other birders. This collective effort allows us to see when birds are in areas and what habitats they are using throughout the year. As a birder, you can use eBird to look up the best birding locations in an area or find the spots for species that you want to see. For scientists, it allows us to assess bird populations and find locations that are most important for conservation. So if you like birds and birding, the global eBird community may be the place for you. So how do we get started with eBird? The main steps are to create your free account, take the free eBird Essentials course, submit birding checklists, explore sightings around the world, and follow the eBird best practices. To save your bird observations in eBird, you'll need to create a free Cornell Lab account. This account works across Cornell Lab projects including Merlin Bird ID, Bird Academy, Project Feeder Watch, and the Great Backyard Bird Count. If you already have an account for any of these other projects, you can use it for eBird and there's no need to create a separate account. If you're brand new to eBird, eBird Essentials is a free online introductory course to eBird and how to use it. There are 5 lessons of instructional videos and other materials that take about 3 hours total. If you use eBird or plan to use eBird, I highly recommend taking eBird Essentials to brush up on information and know-how. Even if you've been using eBird for years, there will likely be some good tips and reminders. A lot of what I'm covering tonight can be found in eBird Essentials. So now you've got an account and you've taken eBird Essentials. It's time to start entering your bird sightings. Observations in eBird are entered in the form of checklists. Whether you submit observations on the website or on eBird Mobile, every checklist should include where you went birding, when you went birding, how you went birding, and which bird species you observed and how many individuals of them you observed. You will also be asked whether your checklist is complete. A complete checklist is a report of all the birds you could detect and identify by sight or sound. A checklist is incomplete if you identified some birds but chose not to report them, such as a list of highlights only. Why is it important to choose an accurate location? Accurately representing where you went birding is critically important to eBird data. Misplaced locations can result in birds being seen where nobody will find them, or direct conservationists to prioritize work in places where the bird has never occurred. eBird science relies on accurately placed observations for output like our status and trends maps. If the locations underlying these scientific products are unreliable, then results may be unreliable as well. Please make your checklist locations as accurate and precise as possible. For example, in Dallas County, Texas, there's only one known location to find golden-cheeked warblers in the spring and summer, Dogwood Canyon Audubon Center. Golden-cheeked warblers are habitat specialists and a species of conservation concern, and this part of the county has the conditions they need. If you saw a golden-cheeked warbler there and misplaced the location in eBird, it could lead to wasted conservation work in the wrong place. Ensuring that your location data is correct means that your personal records will be accurate, other birders will be able to see what birds you saw in an area, and scientists will be able to use the data to build on population models of birds around the world, like this one for barn swallow. Let's cover a couple of things you can do once you've finished birding. The first is sharing a checklist with other people if you went birding in a group. I'll go into a bit more detail on this during tomorrow's talk, but I did want to mention it tonight. When you go birding as a group, say as part of an Audubon field trip, you're all in the same location at the same time and essentially seeing all the same birds. So it makes sense for everyone to share the same eBird checklist. Think of it as not duplicating effort in the database. As long as you've kept the email address for your Cornell account up to date, You can share lists and accept shared lists from others with checklists from both the eBird mobile app and from the web version of eBird. If you saw a bird that the rest of the group didn't, or if you missed a bird that everyone else saw, once you've accepted the list, you can go in and edit it. After you've submitted a checklist, you can go back and add photos and audio you took of birds and habitats at the location. These photos and audio go into the Macaulay Library, an archive of natural history, audio, video, and photographs where they can be used for research and education, help to power projects like Merlin, and even be used in presentations like this. Nearly all the images on the slides I'm using tonight came from Macaulay thanks to contributions from birders like you. One key thing to note on adding photos and audio is that right now, the only way to do this is on the web version of eBird. It can't currently be done through the mobile app. 3 months ago, we added the ability for people to add what's called checklist level media to their eBird checklists. This includes photos of habitats at a location, soundscape audio recordings that have several species of birds without a focal species, photos about the experience of birding as a site, such as trail maps or other unique moments, and the ability to add photos and sound recordings of other animals. As of this week, we're up to 160,000 habitat photos, almost 30,000 soundscape recordings, and 142,000 photos and 36,000 sound recordings of other animals. One of the key things about habitat photos is that when you upload them, you can tag what species of birds you saw in these habitats. Almost 3,500 species of birds have been tagged in habitat photos so far. Our goal is to use this information to build up what we know about the habitats where you can find birds, which is lacking in many parts of the world. We'll use this photo set to verify habitat at a site against other information sources such as satellite imagery, and eventually start adding habitat photos to Merlin and to eBird's hotspot pages. So let's move in how to get started on a checklist. There are two main ways to share your bird observations with eBird. Submit them through the website or with the free eBird mobile app. When entering observations on the website, you put in the where, when, how, and which birds you saw all at once. When using the mobile app, you can hit the green start button visible on that leftmost image here, enter all that information as you're out birding, and then once you finish, stop the checklist timer by hitting the green review button at the bottom in the second image. Check over your observations to make sure they're accurate and submit the list. This is probably a good point to compare the eBird mobile app against the website version of eBird. We'll cover eBird Mobile first. Some key features of eBird Mobile are that it customizes checklists for your location and time of year so it shows the most likely species based on eBird data. It gives you real-time feedback on if a species is rare in the area or if you've seen an unusually high number. Both of these scenarios require extra documentation or notes before they can be accepted into the database. It has quick entry tools so that you can quickly add species, adjust numbers, and enter notes. It has GPS-enabled location plotting and tracking options, and you can summarize your birding activity with life, year, and month lists for any region or nearby location. eBird Mobile allows you to explore area birding hotspots, look up reports of species you haven't seen in an area, see when and where different species have been seen locally, and see directions to birding locations that you'd like to check out. By downloading packs of information for any region in the world, it works even when you're away from internet and cell signal. Additionally, the entire app is translated to over 20 languages, with more on the way. As useful as the mobile app is, the amount of information it holds is dwarfed by what's on the eBird website. Then the Explore tab on the website, you can check out information on every species of bird in the world, look up what birds can be found in different areas, look through photos and audio recordings of birds in the Macaulay Library, check out lists of birds that you haven't seen in an area, and set up email alerts to let you know if someone else reports that bird there, and even take quizzes on photo and sound ID. Let's take a look at a few of the options here. Hotspots are locations where birders often go to see birds. These include parks, wildlife refuges, lakes, trails, and all sorts of other places. There are lots of different reasons to pick a birding hotspot as your location. Some of these hotspot locations keep close track of how many species have been seen there, or want to get the word out to the public about rare, interesting birds seen there. Choosing a hotspot also lets other birders know if they want to visit a location. If you choose a hotspot as your location, it's important to choose the correct one. Sometimes these locations are close together on a map, and some hotspots are for specific trails and locations within larger hotspots, such as national wildlife refuges or national parks. Let's take a look at an example hotspot from here in North Texas. The red pen on the map is the eBird hotspot for Hagerman National Wildlife Refuge. The other markers here are for what are called sub-hotspots, specific trails and locations within the refuge. By clicking on the marker, we can see that eBirders have reported 345 species at Hagerman and have submitted over 10,000 total eBird checklists for the location. By viewing the details of the hotspot, we go to the location's hotspot page in eBird. This page includes information about what birds have been seen here recently, any recent photos or audio that birders have added to their checklist from the location, and a number of tabs along the side, containing even more information about the location. Also at the top, we can see that those 10,000 checklists have come from over 1,400 birders over the years. The different tabs on the hotspot page include a listing of the most recent 200 eBird checklists at the location, so you can see what birds have been seen here by different birders, and an illustrated checklist. The illustrated checklist shows all the species that have been seen at this hotspot, a bar chart of how often eBird checklists report them in every week of the year, and examples of photos and audio recordings of these species that have been taken at this hotspot location. Another section on the eBird Explore page is for species maps. These are maps of all the locations around the world where birders have reported different species of birds. Let's say you want to check all the places where anyone has ever reported a northern cardinal on an eBird checklist. Here, wild populations are shown in purple, darker colors indicating a higher frequency of sightings, and orange shows populations resulting from human introduction. The introduced populations we see here include the Hawaiian Islands, Bermuda, and the area around San Diego and Tijuana. If we zoom in to just focus on Texas, we can see this information broken down into a grid of squares 20 kilometers to a side. Here we can see that their numbers are fairly dense in the eastern two-thirds of Texas before dropping off as you move west into the high plains and the desert. In far west Texas, they're clustered in areas with water, like along the Rio Grande and in the Davis Mountains. And let's zoom in even closer to focus on the Dallas-Fort Worth Metroplex. Nearly the entire map is dark purple, with a few lighter squares and portions of the grid that don't get much birding activity. If we go in even closer still, we'll be able to see individual points where people have submitted checklists where they saw at least one northern cardinal. There are so many checklists reporting them that they cover nearly the entire map. Pins in red show locations where someone has reported a cardinal on the checklist within the last 30 days. Cardinals are a very common species in this area, and the eBird data reflects that. For a view of what this data can do, let's look at the species distribution map for northern cardinal that's been put together by eBird's Status and Trends modeling team. This combines locations of checklists that have reported cardinals, the number of cardinals on those checklists, and the relative percentage of checklists in an area with cardinals on them to produce a finely detailed map of where you can find cardinals and how common they are in those locations. At this point, eBird has so much data from every day of the year that we can track movements of birds throughout the year. This is a Baltimore Oriole. We have enough data to make a map like this for every week of the year, and when you string them together, you get an animation. Here they are in the winter, then migrating north for the summer to nest, and then back down again for the fall. eBird has been around for nearly 20 years now, and we have enough data that we can start to track changes in bird populations over time. This is a map showing how Baltimore Oriole populations have changed over the 10-year period from 2012 to 2022. Areas marked in blue are where populations are increasing, and areas in red are where populations are decreasing. Spots with white dots are where the population is stable. You can see here that Orioles are overall doing really well, especially in the Midwest. In total, their abundance has increased by 12%. They're in decline in the Northeast, especially around the New York City area. Other species are showing negative trends. This is a map showing the great blue herons are in steep decline across the country. Although these maps often show negative trends, they're incredibly useful in helping target conservation actions. This map looks and seems like it would be hard to interpret a clear pattern, but is showing that pinyon jays are increasing in areas with recent wildfires that weren't too strong. This species likes open habitats mixed with patches of open woods in the pinyon juniper landscapes of the western U.S. Historically, in this region, small wildfires would clear out brush and suppress tree growth every few years, so light, regular fires help to maintain their ideal habitat. And we can also see the impact of policy on bird populations. This is a map for bald eagle, which almost became extinct in the mid-20th century because of the impact of DDT on their health and ability to nest. In 1963, there were fewer than 500 pairs of bald eagles left in the lower 48 states. Thanks to major policy changes and a huge amount of conservation effort, the population recovered and they were taken off the endangered species list in 2007. Monitoring them is still pretty important. While this map may look blank away from areas with increases like the Chesapeake and the Northwest, all the dots on the map are white, which means that the population is relatively stable and has actually increased by about 8% overall over the last 10 years. That's encouraging because it shows that conservation and changing policy can work to help birds. So let's go from what eBird can do for conservation to what eBird can do for you. On the My eBird page, there are numerous tools for you to go back and look at your past contributions to eBird. Blue text are links, allowing you to further explore your eBird activity. These values are automatically updated with every checklist that you submit. You can see summaries of what you've seen this year, this month, and this day. Check out how your numbers compare to previous years, and change the region that these summaries look at, from as big as the entire world to as small as a single county. Several tools in the sidebar allow you to sort through and edit observations, with options for checking all your past checklists, renaming, changing, or otherwise adjusting the locations where you've placed checklists, adjusting the list of anyone you've ever shared a checklist with, seeing a summary of all the species you've ever seen, and even downloading a copy of all the data you've submitted to eBird. Another option in the sidebar is to set up your eBird profile. Profiles are another way to summarize your observations, and they show off where you've recently been birding and your latest photos and audio. This information is visible to logged-in eBird users anywhere your name appears, such as checklists, hotspot pages, and photos and audio. We understand that some people don't want to share this information, so you can set your profile to private and hide all of that so that only you can see it. If you don't want even your name out there, you can even set your account to be anonymous. Then only regional data quality reviewers will be able to see your name. The most notable feature of the eBird profile is the profile map, where each region is colored based on your eBird activity there. If you tap Change Region, you can zoom in to a specific country, province, or county. If you click on the statistics at the top to toggle the map display between species, checklists, and media. Another interesting thing on your My eBird page is the ability to create trip reports. If you want to summarize all your checklists from a single birding trip, or even a single day of birding, a trip report will bring all of that information into a single page. eBird trip reports are live summaries, meaning they update automatically as new eBird checklists are added from the trip period. If you create an eBird trip report before your next big day, field trip, or birding adventure, you can share the link with friends and they can follow along with real time as you submit lists throughout your trip. Also on that sidebar and on the Explore page is the ability to set up email alerts. Rare bird alerts let you know about recent reports of unusual birds in a specific county, state, province, or country. AVA alerts let you know about national rarities reported from the US and Canada within the past week. Needs alerts provide you with recent reports of species you have not yet observed in a region. Here's part of what the rare bird alert for Texas looked like earlier this week. A confirmed record on an alert has been reviewed by one of eBird's local volunteer data quality reviewers and is accepted into the database, while unconfirmed records have not yet been reviewed. If you want to find out more about eBird's quality review system, come attend tomorrow night's session. Somewhat similar to needs alerts is the target species feature on the Explore page. This feature creates prioritized lists of species found in a region that you haven't seen ever, or maybe for just that region, or maybe for that region in a year. You can even select for species that you have seen but not yet photographed or audio recorded. These results can be sorted either in species order or by frequency, so you'll know how often the species is seen in the region you've picked. I'll be going into much more detail in all of these in tomorrow's webinar, but I'd like to touch on the eBird best practices. These are ways to make your observations most useful to scientists who use eBird data and to other birders exploring this information, and sometimes both, as seen here in this photo of almost half the staff at the Cornell Lab of Ornithology looking at a golden-winged warbler by the parking lot. Number 1, keep complete checklists. Report all the wild birds you saw while birding. It's important to know that something isn't on your list because you didn't see it and not because you didn't want to include it. Keep checklists short. If you start new lists once you've gone more than 5 miles, or you've been out for more than 3 hours, then your lists will have much more precise information about when and where you saw the birds on them. Choose accurate locations, which we mentioned earlier. Count birds. Having even a good estimate of bird numbers you saw will help birders know if something is common and help scientists build accurate population models. Use mobile tracks. When you use eBird Mobile, it produces a GPS track of the path you followed. This information means that scientists can model bird locations along an extremely precise path. Document your sightings. If you find a rare bird or come across an unusually high number of species, try to take photos or sound recordings to back up that record and put in a good written description of what you saw in your checklist notes. And lastly, share a single checklist when you bird as a group, like with the Golden Winged Warbler fan club in this photo. If anyone here tonight hasn't started using eBird yet, but does have old sighting lists that they'd like to enter, there are a couple different ways to do so. If you have information on the dates and locations when you went birding, you can enter a normal checklist through the website using the historical protocol. If you're just entering your entire life list without information on dates and locations, there's an entire article in eBird's help pages about how to enter your pre-eBird life list. In addition to eBird, the Cornell Lab of Ornithology also provides lots of other useful information about birds that's linked to the data from eBird. Let's go over a few of those. Birds of the World is an online encyclopedia of every bird species on the planet. This includes summaries of any scientific information that has been published on their appearance, nesting habitat, where they live, what they sound like, and behavior. The entries on this encyclopedia can range from many pages long on well-studied species, such as this one for Akia polau, one of the endangered Hawaiian species. Or they can be brief, bare-bones information on poorly known tropical species, such as the riparian antbird here. The entry for this species is just a single page because there's been relatively few scientific publications about its natural history. Another interesting project is Birdcast. Birdcast uses the US NEXRAD weather surveillance radar network to detect and model bird movements during spring and fall migration seasons. We've known that radar can pick up migrating birds since the early 1960s, and the study of nocturnal movements in migrating birds has been very well developed since then. Let's take a look at a 3.5-hour period beginning at sunset on the East Coast from back on May 10th, which was about the peak of migration this past spring. As sunset starts moving inland from the East Coast, we can see that radar is detecting some soaring birds out over the Great Plains, but there isn't much else in the sky yet. 30 minutes later, we start to see birds lifting off from Florida and around Chesapeake Bay. By an hour after sunset, birds are lifting off all along the East Coast with a definite movement to the north and northeast. After another 30-minute interval, bird movement has spread into the Midwest, and then into the Great Plains. As sunset crosses over the Rockies, we start seeing our first movement of the evening through Texas. And by now, the sky over most of the country is filled with birds on their way north. The numbers continue to increase for another hour and a half on this particular night, topping out at an estimate of over 450 million birds in the air before migrants either started landing or got far enough into Canada to leave the range of US radar. Why is this data important? Well, for one, it can help us predict which days will be best to go birding during migration. I check the Birdcast info and the radar data first thing in the morning every day that I run my migration study so that I can have an idea of how busy I might be. Additionally, there are conservation applications. I think most of us are aware that there's a lot more light at night than there used to be. Looking at this NASA image of the US at night, all the different cities and towns are lit up like Christmas trees. The vast majority of birds migrate at night, and they've spent millions of years adapting to finding their way in the dark. Some of them even navigate by the stars. Throw a huge amount of man-made light into the landscape, and it can be very disorienting for nocturnal migrants. One of the biggest human-caused sources of bird mortality is collisions between birds and human structures, most especially glass windows. And most of these collisions happen at night, when birds have been disoriented by lights or trying to find their way out of urban areas. Data like the radar imagery used in Birdcast can help us to reduce the effects of light pollution on migrating birds through voluntary programs like Lights Out. By seeing when birds are moving through an area in large number, we know when would be the best times to reduce the amount of lights at night. Bird Academy offers online courses about all kinds of topics related to birds, ranging from as easy as eBird Essentials to as complex as Cornell University's actual ornithology class. Some, like eBird Essentials, are free to anyone, while others, like the college course, are more expensive. One exciting development from the past few months is that the translation team at the lab is starting to translate these courses into other languages. The How to Record Bird Sounds course is about to be available in Spanish. Now let's move on to another educational tool provided by Cornell, one that's free and that you download onto your phone. And that's Merlin. Part of the mission at the Cornell Lab of Ornithology is to help people find the answer to what's that bird. We know that sorting through a massive field guide, using search engines, and other resources can make it really challenging to figure out what you just saw when you're just starting to learn your birds. And our goal is to make that challenge easier. Merlin, which is named after both the wizard from the King Arthur stories and the species of falcon found throughout the Northern Hemisphere, is designed to be a birding coach for bird watchers at every level. Nearly 12 million people around the world have downloaded Merlin, and a few 100,000 use it every day. Merlin has three main methods to help you identify birds. The first is by having you answer questions about a bird that you saw. This includes where you saw the bird, what habitat it was in, how big the bird was, what colors it was, and what sort of behaviors it was exhibiting. These are the sorts of questions an experienced birder might ask when trying to help figure out an ID. The second method is photo ID. Remember when I mentioned back at the start that eBird users have uploaded over 73 million photos of birds to their checklists? The software engineering team at the lab has created a machine learning model that can run through thousands of images for each species and look for the shared patterns in those images. With enough photos, the photo ID tool can correctly identify images of birds in different postures and from different angles. With the most recent update in last November, Photo ID now includes 6,900 species from around the world. Merlin uses machine learning, which is what people refer to as AI, to identify birds in photos. And for it to learn how to identify a bird in a photo, we have to teach it what that bird looks like. If you were learning how to identify birds, you might use flashcards. I could show you this flashcard and let you guess what it is. If you correctly say that it's a blue jay, I could tell you you're right. If you get it wrong and you say it's a cardinal, I'll tell you you're wrong. You hopefully learn from the mistake and we try again. You might try looking at blue jays from different angles or in flight to make sure you know what they look like in any situation. This is essentially how we train Merlin. The flashcards we use to train Merlin are the photos from Macaulay Library that were submitted on eBird checklists. We have 161,000 plus photos of blue jays, which is great because that's opportunity for us to teach Merlin what they look like. We take these photos and we annotate them by hand drawing a box around where the bird is in the photo. Then we use these annotated photos like flashcards to teach the computer model how to identify birds. Just over 1,300 expert birders from around the world have annotated 1.5 million photos for this project, which is about 2% of the total photos in the Macaulay Library. Each of these photos is shown like a flashcard 200 times each, which takes the computer about a week to process. To put that in a more human perspective, if you looked at one flashcard per second, it would take you 38 years to go through that many photos. All of that training results in a machine learning model that can identify many species of birds with up to 95% accuracy. And then we have Sound ID. Sound ID uses the microphone on your phone to listen for birds. If it detects a bird singing or calling, it tries to identify that bird based on what species are likely in your area on that day of the year. This is what I work on. Sound ID works in a really similar way to photo ID. Merlin uses spectrograms to identify birds by sound. A spectrogram is the visual representation of the sounds. Reading them is a little bit like reading music. When you start Sound ID, the first thing you'll notice is the spectrogram scrolling across the screen. Each bird species makes a unique song, and that song makes a unique shape on the spectrogram. I'm going to play a wood thrush's song here as an example. I'll play it and you can watch and see how the different notes it sings make different shapes on the spectrogram. That may be a little fast to see clearly, so I'll slow it down to a quarter speed. Sound ID is powered by hundreds of thousands of annotated spectrograms from sound files in the Macaulay library, nearly all of which were uploaded by birders to eBird checklists. Experts in regional bird sounds go through files and draw labeled boxes on the spectrograms around the songs and calls of the target species, as well as any other bird vocalizing within 3 seconds to either side of a target vocalization. The Sound ID model requires a minimum of 100 recordings for a species in order to start learning the spectrogram patterns for their songs and calls. This minimum number of recordings usually ends up being a lot higher because we need recordings that are at least 9 seconds long and preferably longer. We only use a maximum of 1 recording per species per checklist so that we're less likely to duplicate individual birds in our sample set. And we try to get a sample set that covers the entire geographic range of a species so that we're including all the different regional dialects for that species. For example, here's the map showing all the recordings with a box for song sparrow vocalization that are currently included in the Sound ID model. The different colors indicate different categories. Some recordings train the model, and others are used to test how well the model recognizes the patterns. This is a species that occurs across most of North America and has considerable variation in both plumage and voice. Populations at the corners of their breeding range, in the Northeast, Arizona, the West Coast, and Alaska, can look and sound different from one another. There's generally a slow change from one group to the next over hundreds of miles. Here we have the Northeast in the upper left corner, Arizona in the upper right, Alaska in the lower right, and the West Coast in the lower left. Let's go through and hear what song sparrows sound like in these different corners of their range. Going back to the map, when we compare this to the full geographic distribution of the species on the right, we can see that we've done a decent job of sampling audio from across their range, although there's always room for improvement. If you happen to have recordings of song sparrow from central Canada, the northern Great Plains, the Rockies, or the southern US, we could definitely use more examples from these regions. After all of these annotated spectrograms have been used to train the Sound ID model, the final product ends up in your phone. When you see Merlin, it's not really listening. It's actually looking at the spectrogram image and comparing what it sees to what it learned from those files that have been annotated. Merlin looks at the spectrogram in 3-second chunks. So here in this recording, Merlin can see that the first chunk contains a song of a western meadowlark. Then it shifts the box over by 1 second and checks again. Meadowlark is still here, and so is a common yellowthroat. Then it shifts the box over by 1 second and checks again. Here we have the meadowlark song and the yellowthroat, and we also have a second meadowlark calling.
Blaine,
This is what Merlin. Yes,
we're not hearing your sound.
this one isn't playing a sound.
We didn't hear the other ones.
It may not have come through. Zoom sometimes has trouble with audios.
Okay, thanks.
So this is what Merlin is constantly doing when you're using it on your phone outside. So far, we've trained Merlin Sound ID in just over 1,700 species of birds in the world. This includes pretty much every bird you're likely to hear singing in the US and Canada, as well as common birds from Central and South America, Europe, India, East Asia, and Australia and New Zealand. We're working now on training Merlin to work in the rest of the world. The first few species from Australia were added earlier this year, with more on the way for our next update in a few months. And we're beginning to work on adding species from Africa and Hawaii. Our goal for the next update in October is to add another 300 species, as well as increasing the accuracy for species that are already in the model. So depending on where you are in the world, Merlin could be able to identify a high percentage of your local birds. A little over 400 expert birders around the world have worked on Merlin Sound ID, and we've drawn boxes around over 3.5 million bird songs and calls on more than 300,000 different audio recordings in the Macaulay Library. That's over 10% of all the audio recordings that have ever been contributed to eBird. And we still have a long way to go. There are many species of birds in the world where we're short on recordings, so we need as many audio files as we can. Before you start using Merlin, there are a few things to keep in mind. First, as amazing as Merlin is, it can make mistakes. The bird ID suggestions it gives you are a starting point, and before reporting its suggestions on an eBird checklist, you should try to verify them by seeing and hearing a bird for yourself. Second, set your location. Merlin is most accurate when you allow it to use the location services on your phone. Otherwise, it will try to make its predictions based on all the birds in the world, rather than the expected ones in your area. Third, if you use eBird and Merlin together, try to add some of your sound recordings from Merlin to an eBird checklist. The recordings will go into the archive and help Merlin become more accurate. If it suggests a rare species, then definitely add that recording to your checklist. Remember, audio recordings are a great form of documentation. Fourth, before you upload recordings, check out eBird's audio editing and preparation guidelines to make your recordings better quality. If you want to see tomorrow's webinar, I'll be going into that in some detail. Lastly, use good recording techniques. Get closer to birds so that they sound louder in a recording, and don't walk or talk when Merlin is running, because loud background sounds make it less accurate. Sound ID tends to work best in short intervals, so try to keep recordings to just a few minutes at a time. I'd like to thank everyone again for wanting to spend your evening with me. We've covered a lot of things about both eBird and Merlin, and I hope all of y'all have gotten some useful information tonight. eBird and Merlin are powered by the contributions of the birding community around the world. So if you're already a regular user of eBird or Merlin or both, thank you for everything you've done. And if you haven't started your eBirding journey yet, I hope this inspires you to join in with us. It's getting a little late, but for those of you who want to stick around a while longer, I do have time to answer questions.